Welcome again to Educator.com, Intermediate C++. Today we'll be talking more containers, specifically set and map. All right, sets and maps have a slightly different data structure from a linked list. They have a binary tree which gives them fast access. Now there's a certain cost in that for your insertions and deletions, but it's worth it for the fast access for sorted objects. And we will introduce a pair object real quickly, and we will introduce the containers set and multi-set, the difference being the set unique keys, multi-set can have multiple keys, duplicate keys, right, it says right there. And they're sorted automatically. It's kept in a binary tree, it's kept in order, and as soon as you add a new node, it will go look, where does this go, and it'll put it in order. Multi-set allows duplicate values, and we'll talk about how to get data in and out of a set or a multi-set. And we'll also introduce map and multi-map, same type of thing, where the map is unique keys and multi-map is duplicate keys. The difference between a map and a set is a map maps one value to another value, and we'll talk about how to get data in and out of maps and multi-maps, and how to provide a custom class for doing the comparisons. Just how do we know that these two guys, well, this guy belongs in front of this guy? If it's integers or doubles, it's not a problem. If you have custom class, you may need to provide a function that says this class object needs to go before this other class object. So you give it a class for that. And what happens if you try to put in something into a set or a map and it's a duplicate, it's not allowed to go in. How to make that determination. So here we have a tree structure. These are basically the same integers in the same type of thing that we had in the linked list last time, only now we have a tree structure. So we go into here and we're looking for a specific number. Let's say we're looking for 150. 150 is less than 267, so we go that way. It's more than 139, so we go that way. It's less than 205, so we go that way. Ah, there it is, 150. Now, if we were looking for 149, we'd go through here and say, well, there's no more after that, so 149 is not in here. And you may need to add it if you're going to add it. Well, let's see, we have 271. We go blah, 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 blah. 271 is less than 275. So we would erase that. And now it points to there. And then this guy is null terminated. Now you say, well, what's the value of this? Your value is in searching. Let's say we're looking for, let's something nice and low. It's 342, way down here. If you have this in an array, if you have this in a linked list, you're searching through it. So is it 15? No. Is it 27? No. Is it that one? No. That one? No. No. Blah, 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 blah. Search, 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 and then you finally find, there it is. Whew. All those searches before you get to it, that's very time consuming. Binary tree, we start here, is it 267? No. It's greater than 267. We go down here, it's less than this, it's greater than that, so there it is. So it's 1, 2, 3, 4 searches, bang, there you are, very fast. There are other types of trees that are n array, you could have 3 of them instead of 2. You have any number of them. You say, well, we'll divide our, it depends on what your data is. This is arbitrarily evenly distributed because I took the data and I built a tree around it. When you get the data and you start constructing your tree, it may not automatically come out this way. If it's poorly distributed, you could have, like, for example, lots of nodes all going in this direction. So if you're searching for something that's above that, it's very fast. But if you're searching something in this area, it could be very slow because it's not distributed well. And there's all sorts of algorithms and systems to keep your trees balanced. But we're not going to worry about any of those because all this will be taken care of for us by the system.